Here we aim to solve x to the fourth plus 2x squared minus 3 equals 0. And this is kind of strange because it looks like a quadratic equation, but it's a degree 4 equation, which is not a quadratic equation. But there's a trick to this kind of problem. This is called quadratic in form. Let's rewrite it a little bit. What if we said this? Instead of x to the fourth, what if we wrote x squared squared plus 2, and now I'm going to put this x squared in parentheses, minus 3 equals 0. Now it really looks like a quadratic equation. And so there's a couple ways to do this. I'm going to show a method called substitution. It's called substitution. And what that does is we say, okay, you can choose a variable. I like u or m are usually kind of the standard substitution variables. Let u be x squared. Okay, well, why would we do that? Well, notice that if we let u be x squared, what does this become? This becomes u squared plus 2u minus 3 equals 0. And substitution is a really good skill to get down because when you go into calculus, you'll be doing a lot of substitutions up through there. So it's good to start learning this method now of substituting one variable for another. Although you could just go straight to factoring and leave it in terms of x squared, you'd still get the correct answer. The world's not going to end. So up to you, though I recommend just doing everything with substitution so you get familiar with it. Okay, so now look, we can factor this. Look how much easier this is. This is something we factor. The downside is we're going to have to pay this substitution back by back substituting at the end here. So let's factor this. We have u and u. We need factors of negative 3 that add to positive 2. So I'm thinking we'll do plus 3 and minus 1. Setting both of these factors equal to 0 gives u equals negative 3 and u equals positive 1. These are not our answers because remember, u is x squared. So we need to back substitute because we're not interested in what u is. We're trying to solve this thing for x. So now we say, okay, well, u is really x squared, so that gives x squared equals negative 3 and x squared equals 1. Okay, so we solve each one of these out. Let's see, we can take the square root of both sides. Don't forget the plus or minus. That's important. Anytime we take the square root as part of solving an equation, we make sure to put on that plus or minus there. That gives us x equals plus or minus I rad 3. That negative came out as an I. Okay, square root on this other side here, plus or minus, just gives us x equals plus or minus 1. Okay, so there are 4 solutions to this. Plus or minus I rad 3 and plus or minus 1. Let's try another one. This one is slightly more complicated. We have 9x to the fourth plus 5x squared minus 4 equals 0. Again, this is quadratic in form, and we use quadratic methods to solve it. So I'm just going to rewrite it to make that a little more clear. Right? We can write this as 9x squared squared plus 5, and this whole thing is x squared, minus 4 equals 0. And maybe you can start to see how it starts to look more and more like a quadratic equation here. We can do a substitution. Let's see, let u be, and it's always the one attached to the middle term. So we have a squared term and then what we call a linear term or a b term, and then we have our constant. So you want to let u be whatever is on that middle term, assuming you have it in the correct order, written in this nice descending order, and it's a trinomial. So let's let u be x squared. Okay, well, good news, this becomes simpler. 9u squared plus 5u minus 4 equals 0. Now we need to factor this. So let's go ahead and do that. We could use trial and error. I think instead I'm going to use the diamond method, which works like this, right? You do your x's there, a little straighter. Okay, AC goes here, AX goes here, AX goes here, division line, and B goes down here. Okay, so let's do that. And recall, of course, this is A, B, and C. So AC is negative 36 and B is 5. So we want factors of negative 36 that add to 5. Okay, well, 1 and 36, no. 2 and 13, no. What else can we do? 9 and 4 is sounding pretty good because I can mess with the pluses and minuses of 9 and 4 and get to 5. So 9 times 4 is 36. Let's tweak these negatives just to make it work out right. This is positive 5, so we need the bigger number to be positive, so I'm going to say that this is going to be 9 times negative 4 to make our 36. Okay, and then AX goes here, so this would be 9x and 9x. All right, and then we have plus 9 and minus 4. All right, simplify that down. Right, these cancel, so this is really just x over 1, and then that gives us our factors, right? We read from the top down like so. So the factored form of this is, so I wrote it in terms of x, but really we're dealing with u's here, so I'll switch back to u's. So it's u minus 1 times 9u minus 4 equals 0. That's what we're solving. Okay, setting each one of these equal to 0 gives u equals 1, and over here we get u equals 4/9. Okay, but we don't actually care about u. U is actually x squared. So we back substitute that in. I'll go up here with it. We have x squared equals 1. Take the square root of both sides. Tack on a plus or minus. That gives us x equals plus or minus 1. There's two answers. All right, and then we also have u is 4/9, so that gives us x squared equals 4/9. Square root both sides. Tack on a plus or minus. That gives us x equals plus or minus 2/3. All right. 4 answers to that one, plus or minus 1, plus or minus 2/3.